Hey guys, it's Saha, and today I'm going to be speaking to you a bit about this interesting technique that a few astrophysicists developed in order to calculate the surface gravity of a star pretty far away. The technique is known as the autocorrelation function timescale technique, or timescale technique for short. The surface gravity of a star is the pull of gravity it has on other objects. If we were to check our weight on many stars, it would certainly change due to many different factors such as mass and diameter. Although due to the massiveness of the Sun, we would be 20 times heavier on its surface than on Earth, on a red giant star that may seem to be the same size, we would weigh much less due to its weaker pull. In fact, researchers say up to 50 times lighter than what we weigh on Earth. Stars that resemble the Sun as closely as possible are much more likely to have planets that are closer to the Milky Way planets, such as the Earth orbiting around them, which means life. So scientists have been trying to find stars that have a gravitational pull similar to that of our suns. Calculating the diameter and the mass has been accurately used for stars within a certain range of observation. For stars that are farther away, this technique works not so well. Simple, yet an effective innovation, the timescale technique takes a different approach. In order to calculate the gravitational pull, it takes into account the variations in brightness of distant stars which are observed through satellites like NASA's Kepler Space Telescope, in order to find a star that is similar in brightness to the Sun. The new method allows scientists to measure surface gravity within an accuracy of about 4%. Since surface gravity depends on the star's mass and radius, just as your weight on Earth depends on its mass and radius, this technique will also enable astronomers to better guess the masses and sizes of distant stars. The pull of gravity of a star can be very instrumental in the search for life in our universe and to discover planets that may already or may potentially harbor life. If you don't know the star, you don't know the planet, said study co-author UBC professor Jamie Matthews. Quote, the size of an exoplanet is measured relative to the size of its parent star. If you find a planet around a star that you think is sun-like but is actually a giant, you may have fooled yourself into thinking you found a habitable Earth-sized world. Our technique can tell you how big and bright is the star. If a planet around it is the right size and temperature to have water oceans and maybe life, end quote. Callinger, the study's lead author, adds, quote, the timescale technique is a simple but powerful tool that can be applied to the data from these searches to help understand the nature of stars like our Sun and to help find other planets like our Earth, end quote. I personally found it interesting that sometimes little things can be overlooked or underestimated in science, and how it took so long to take into account brightness of stars to find their gravitational pull. I was also interested to know that the universal gravitation formula is not so universal. I have a few questions for you. Do you think scientists sometimes overlook small details while trying to focus on the big picture and a lot of times miss out something essential? Can you think of any examples? Also, how do you feel about a 4% accuracy? Is it sufficient, or should new methods constantly be developed? Thanks for watching. Catch y'all soon.